I think the traditional one-to-one comparisons may not be quite meaningful when we're comparing Turing to the old Pascal GPUs. Hey guys, this is Kevin for Pixavert.com. In this video, we're going to be looking a little bit closer at the new Turing GPU that Nvidia announced in the last week. Now, what I wanted to do was to dive in, take a little bit more of an intense look at what this GPU involves, why it's different from Pascal. We're going to be comparing it to Pascal and looking at some of the implications of what Nvidia have just dropped. So Nvidia have said that this is the greatest leap since 2006 CUDA came out. It's a new hybrid rendering model, includes ray tracing, real-time computing and AI. But what does all of that mean? So this is the actual Turing chip itself. We've got display, NVLink and video on the right, Turing SM, RT and Tensor Core on the left. Let's start off with the right hand stuff because the really interesting stuff is on the left, and we're going to finish off with that. We're going to look at the display. It's got 8K DisplayPort and Virtual Link. Virtual Link is a technology that allows you to pump out a huge amount of data to a virtual reality device. NVLink is a way of connecting to GPUs, sharing memory, and it's much faster than using PCIe. And down for video, we've got HEVC 8K real-time encode. So those of you guys that need real-time encoding at 8K, this thing is capable of that. Over on the left, we've got the traditional Turing SM. This is the CUDA core, the shading, the stuff that you do traditionally in terms of parallel processing and also in terms of traditional graphics. Now we've got the RT core. This is taking up this area here. So the RT core, sometimes referred to as the real-time ray tracing core. These are the parts of the GPU that no one really seems to understand because we haven't got the details of this technology. But these parts of the GPU accelerate the ray tracing so that Nvidia can bring that good ray tracing stuff onto the platform for gamers. The Tensor cores are for AI. This turns out to be an important part of improving the performance of the GPU because the Tensor cores can support the ray tracing cores and the ray tracing cores can support the traditional graphics. So ray tracing turns out to be something that Nvidia have already worked on.
Stress just flows right out of my fingertips. This is going to be a good day. I am going to do a good job.
Back in 2012, believe it or not, they had real-time ray tracing and they had that on the Kepler GPUs. So this is something which has been evolving with Nvidia. I think what they're trying to do with this particular GPU is to introduce some synergies.
That would be an example.
Ray tracing at 10 gigabaytes per second is really quite powerful. The performance, when you compare that with what we're currently...
So the artificial intelligence is going to support the real-time ray tracing. The real-time ray tracing is going to support the traditional computing. And this would allow what Nvidia are saying is going to be 25 times the performance in real-time ray tracing over the Pascal generation. They're also saying that this chip is 6 times faster than Pascal. Let's take a look at the comparison between Pascal and Turing.
A few technologies that when in combination in this RTX platform, when you put them together, does this. Isn't that amazing, guys? A 6x speed up in computer graphics, a 6x speed up in computer graphics. Well, the way that it's done is we, number one...
So here we are. We've got Pascal on the left, Turing on the right. You can see the Turing chip is much larger. It's not as large as Volta. Volta, however, does not have the RT cores. It just has tensor and the traditional computing and shader cores. The Turing chip is 754 millimeters squared and Pascal is 471 millimeters squared. It's going to be difficult, I think, to have a straight one-to-one comparison between Turing and Pascal because they're fundamentally different. So I think it's going to be interesting to look at the benchmarks. Talking about benchmarks, UL Benchmarking, the old FutureMark, have already said that they're going to include real-time ray tracing as part of their benchmarking. So that's the kind of thing to be looking out for in future. I think the traditional one-to-one comparisons may not be quite meaningful when we're comparing Turing to the old Pascal GPUs. This is the Nvidia page for Nvidia RTX, and they're saying applications built on the RTX platform bring the power of real-time photorealistic rendering and AI-enhanced graphics, video and imaging processing to enable millions of designers and artists to create amazing content in a completely new way. The completely new way, yeah, it's going to be new, but like I said, real-time ray tracing has been around since Kepler. So I think what's really new is that they're trying to mix the ray tracing with traditional rendering techniques, which is why they're talking about a hybrid between the traditional and the new, the rasterization, which is what they're calling traditional rendering techniques, and the new ray tracing technique. So I think developers will be able to build ray tracing on top of traditional techniques. And it doesn't actually say it here, but the ray tracing is going to include audio ray tracing, which is something a little bit new for me. I've not heard of that before. So it'll be interesting to see what the audio capabilities of their ray tracer is. The artificial intelligence bit here is important also, and Nvidia are talking about what they call the Nvidia NGX SDK. If that doesn't mean anything to you, it doesn't mean anything to me. SDK is a development kit for developers. So let's take a little bit of a look at what's happening in terms of the artificial intelligence. I think if we can see some kind of examples, we'll be able to understand what's going on a little bit better. So this is an example which I think would be of interest to people doing photography, maybe even videos. Let's see what they say here. This is AI UpRes. AI UpRes increases the resolution of an image or video by 2, 4, or 8 times. And unlike traditional filtering methods which stretch out blah 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 blah, AI UpRes creates new pixels by interpreting the image and intelligently placing data. Creates new pixels. So this thing can actually create information. This results in a sharper enlargement that correctly preserves the depth of field and other artistic aspects. The AI image is sharper, the details are better, it does improve the overall rendering. They can also work with videos to make videos that are slow motion, even more slow motion, and there's a whole kind of article about that here. Another really interesting thing is what they're calling AI in-painting. In-painting allows the removal of existing content from images and uses NGX to replace the removed content with a realistic computer-generated alternative. So if you've ever used resynthesizer or content-aware technology, you will know what they're talking about. You can remove something and the artificial intelligence will quickly replace it with something appropriate for the image. This is amazing stuff, and I think what's really important is that once we start seeing this technology inside of our software, if it's running GPU accelerated, it should be running quickly. That's what I think is really going to be important here. So there are other aspects of the artificial intelligence. Dare I say some of it might be a little bit controversial. They can remove noise. so your noisy, grainy photographs may be improved by artificial intelligence. And again, it's actually creating information. It's not just removing or smoothing out the noise. It's actually adding new information. It's working creatively. That's what's really spectacular about this new technology. Here we've got all sorts of text removed from photographs, so goodbye non-digital watermarks. And there's a whole video that they've got here about how you can actually improve grainy photographs. So I can see this technology being used maybe to improve archived materials which are old, grainy, and just need some, modern AI intelligence to improve them. This is another look at the noise reduction. So they've got the noisy input. They've run artificial intelligence, and this is the image that we're looking for. This is what we want to get. This is what artificial intelligence creates by looking at this image here. And there are all kinds of different uses that this might be put to, but you can see the potential for this kind of technology. And again, this is something that we might see in software maybe a couple of years down the line, maybe sooner, who knows. Another thing which is really fascinating is this ability for the artificial intelligence to be trained to actually create artistic works. Here we've got a photograph which has been applied to a trained artificial neural network, and this AI has used this image here to create a style for this image, and we get this really artistic looking portrait. This is the kind of thing that artificial intelligence can do already, and there are all kinds of different ways of achieving this result using artificial intelligence. This is just something that Nvidia are looking at. I don't think this was actually rendered on the RTX platform. It was rendered on previous graphics cards, but obviously as the RTX platform comes along, it should be able to do this kind of thing more quickly. I think there are a lot of interesting stuff to look out for over the next couple of years. Before that though, we're going to get the announcement on the Geforce RTX hardware. It'll be interesting to see what sort of direction Nvidia are taking their Geforce gaming cards in. I'm really looking forward to that. That's going to be it for this video. I hope you enjoyed some of that. Hit the like button if you found it useful. Subscribe for more videos, and I will see you later. Bye.